Hello, my name is Natalie, and I'm going to show you my group CS236 project, which is called Learning to Groove, Conditional Bassline and Melody Generation. For our project, we were interested in using deep generative models to produce music. Many existing models for this type of music generation tend to produce melodies that are somewhat meandering without following a specific chordal structure. So specifically, we wanted to explore whether using conditional generation techniques could provide generated music with more structure without hampering its creativity. So to do this, we present an architecture for an artificial jam session using a dual LSTM consisting of a bass track model and a melody track model, which is conditioned upon the output of our bass track model. To train our model, we obtained our data from the LAC MIDI dataset, where we specifically used the piano and bass track songs. To encode these MIDI tracks as input to our artificial jam session architecture, we devised a three-part encoding for these notes, where each note is composed of a pitch, which defines what the note is, a duration, which is how long the note plays for, and finally an advance value, which represents the duration until the next note plays. This is best illustrated through the diagram on the right, where the MIDIs are visualized with our encoding. Note that oftentimes advance is not the same as duration, which is key in creating polyphonic tracks, which essentially allows multiple notes to play simultaneously. As for the architecture of our artificial jam session, we utilized two multi-layer LSTM models, one for the bass track model and one for the melody track model. In our setup, we train the bass track model first on the tokens from the bass-only dataset, and then we train the melody model with the tokens from the piano dataset, augmented with the information provided from the pre-trained bass track model. This information being the averaged hidden state representations as an aggregate encoded representation of the bass track. And finally, our training signal is provided by cross-entropy loss. For our results, we found that quantitatively, conditioning on the bass track offered very minor improvements in log likelihood. However, qualitatively, our dual LSTM model produced significantly more coherent bass and piano samples. So first, let's have a listen to a sample from the unconditional version of our model. Notice that the bass track and melody diverge stylistically, creating something that isn't very coherent. Next, I'll play a couple samples from our conditional model, and we can notice the improvements.